All right, so right at this juncture, we're looking at we calculated the acceleration as being 4,900 meters per second squared when she hit the ground, because that was the number of G forces that they said that she hit that a cheerleader would hit the ground with. If they threw her 18 feet in the air, nobody caught her, and she didn't stop at all. Okay, but now let's figure out how long she was in contact with the ground. Okay, if the final acceleration, and I'm going to say that since she was going down, now here's how we do it. Here's the way a physicist would look at this problem. Okay, all right. So, or a brilliant physics student like you all. So, and in physics, we don't like to draw a lot of fancy pictures. I kind of do. I draw a lot of pictures in class, but cartoonish type things. But let's just say her center mass, she's going down, and her speed keeps increasing. So I'm going to draw these vectors so that it shows that her speed is increasing like this. So each one of these would represent a vector at a certain speed. Like at this point, she's going, like 1 meter per second, then 3 meters per second. Then at the end, she was going close to 10 meters per second. You calculated the exact amount. Now, what happened was, so that's negative 10 meters per second because it's going down. Okay? And then they said that her acceleration then was equal to a positive 4,900, because to get this to come to a stop, I need to apply an acceleration that's going up. Well, that makes sense. See, physics is easy. That makes sense. And so my acceleration going up is 4,900 meters per second squared. Well, the definition of acceleration is equal to my final velocity minus my initial velocity, v naught, my initial velocity, divided by the change in time. Now that looks complicated to some of you, and I've got to tease this t out of here. Oh my. We can do that. Well, let's write the equation this way. So what do? I multiply both sides by t, where I know that v final is equal to 0, and I know that v naught is equal to negative 10. Right away, some of you are panicking. You're going, oh my God, I can't do this. Sure you can, because I'm going to tell you two numbers. It's going to turn out we're going to divide two numbers, and you're going to get it. Okay? You're going to be golden. So here we go. So we go, all right, so the acceleration, let's do it all algebraically. Let's do it really scary. Let's do it all algebraically. So is equal to v final minus v naught divided by t. Okay? Multiply both sides by t. All right? Is equal to v final minus v initial. Okay? Well, I've got at is equal to v final, which is 0, minus negative 10. Okay, because that's what v initial was. So minus minus is positive 10. A is 4,900 times t. And so t is equal to 10 divided by 4,900. And so the amount of time that the impact lasted is 10 divided by 4,900. And we wind up with 0.002 milliseconds. 0.002 seconds. Ba-boom! Ouch. And it really hurts. What really hurts, what if she'd have bounced up at 5, let's take the change in velocity with the same amount of time that was in, and let's see what that acceleration would be. If she actually bounced, what the force would, and then the force would be the mass times that acceleration. So let's say she bounced and had a final velocity of, let's say positive 3 meters per second. In other words, she bounced in the air. This is bouncing up. You're done at this point with your problem. So let's say she bounces back up. This is why hail damages your car and rain doesn't. Okay? A raindrop's about the same mass as hail. It just hits your car, and the impact lasts for a lot longer. Okay? The impact lasts so therefore the force is a lot less. And she bounces back up. Oh my. Well, let's plug it in here where we've got AT. And we're going to say the T is still the same. is equal to 3 minus 10, negative 10. So that comes out to be positive 13. And so my acceleration then, if the time is still the same, 13 divided by 0.002, whoa, 6,500 meters per second squared divided by 9.8. 600, that's 663 Gs. And that's really what happens. This isn't an answer that we're looking for, but I'm just showing you that the 500 Gs that we found before, if she bounced back up, then it really hurts. So that's why, so what happens when you're on AstroTurf? You bounce back up. What happens if you're on concrete? You can bounce back up. What happens if you're on a gym floor? You bounce back up. And so the G-forces are a lot stronger, and it can kill you. This is, or at least make you an invalid for the rest of your life if things go wrong. All right. Well, that got dramatic. Okay. I think you'll be able to finish the rest of this little thing.